Welcome back to Lesson 6. Lesson 6 is about a linear differential equation, first order linear differential equation. First order means that the differential equation contains only the first derivative of the function y prime. And linear differential equation means that the structure of the equation is the following thing. So the structure of a linear differential equation is v dy v dx plus p of x by y of x equal q of x. And the challenge is to solve these kind of differential equations. So this form is named a standard form. So if you see an equation like, for example, 3x y prime plus y equal e to the x, you need to transform the equation to the standard form. So you divide by 3x, so it would be y prime plus 1 divided by 3x by y equal e to the x divided by 3x. So the q of x will be e to the x divided by 3x. And the p of x, the function p of x, will be 1 divided by 3x. And the challenge is to find who is y of x. And this is a linear differential equation, first order, and this is the structure. If the structure is not like this, is not exactly like this is not linear differential equation. If it appears, for example, a square root of y, this is not linear differential equation. So let's go now to learn how to solve linear differential equation. The key things to solve linear differential equation is to pay attention to this factor, e to the integral of p of x ddx. In our example, will be e to the integral of 1 divided by 3x ddx, or it will be e to the 1/3 the integral of 1 divided by x ddx. And this integral is e to the 1/3 natural log of x, which is equal to e to the natural log of x 1/3, which is equal to x 1/3. So the integrating factor is x to the 1/3. Now, what is the magic of this integrating factor? The magic of this integrating factor, that sometimes is called like mu of x in some textbooks, or u of x, because it's a function that depends on x. Depend on x, you see, is u of x or mu of x. The magic is that if you multiply your original equation by mu of x by the integrating factors, you solve the equation. You find y. Let's go to do it. So we multiply by the integrating factor. The integrating factor is x 1/3. We multiply our equation by x 1/3. So it will appear x 1/3 3x. It will appear here x 1/3 3x. Now the magic is that I can compress these two terms as the derivative respect to the x of x to the 1/3, the integrating factor by y. The derivative of this will be all this, the left side of the equation. Now you can check that this is true, that the derivative respect to the x of x 1/3 multiplied by y is the right side of the equation. So instead of solving my original equation, I'm going to solve this equation, this one, using the integrating factor. And this one, it would be much more easier to solve. I remember that I want to find who is y of x. So if I integrate at both sides of the equation, the y can be solved because the integral of the derivative of a function is the function is x cubed multiplied by y. Let's go to practice how to do it. Now, the first question says determine whether the differential equation x cubed y prime plus x by y equal e to the x plus 1 is linear. A linear differential equation is on the structure y prime plus p of x by y equal q of x. So we have the equation x cubed y prime plus x y equal e to the x plus 1. Now we need to divide by x cubed to make it to appear like the standard form. Let's go to make it to appear. So it will be y prime plus x divided by x cubed, or 1 divided by x squared, equal y plus e to the x plus 1. Divide by x cubed. You divide the other by x cubed. So we conclude that this equation is a linear differential equation where p of x is 1 divided by x squared and q of x is e to the x plus 1. Divide by x cubed. And the solution is, the final answer is yes, is a linear differential equation. Second problem, it says determine whether the differential equation y prime minus y sine of x equal x y squared is linear. Well, the structure of a linear equation is y prime plus p of x by y equal q of x. So it's something in the right side of the equation that depends only on x. I have y prime. I have, for the equation, I have minus. I have the y and I have sine of x. So the sine of x minus sine of x, p of x, should be minus sine of x. What will be q of x? Q of x will be x by y squared, but x by y squared does not depend on x, depend on the function y. So this is not q of x. So this is not a linear differential equation. Let's go to the next one. The third problem say verify that the equation that the function y of x 1/2 e to the x plus c e to the minus x is a solution of the differential equation y prime plus y equal e to the x. What I will do? They say that y of x is the solution. So let's go to find y prime of x. Let's go to solve it, to sum it with y itself. And let's go to see if this is e to the x. If this is e to the x, this is the solution. So they say that y of x is 1/2 e to the x. So y plus c e to the minus x. So who is y prime of x? Y prime of x is 1/2 e to the x minus c e to the minus x. Okay, so I have to add it to y prime, I have to add y. Let's go to add y. So 1/2 e to the x minus c e to the minus x. And I have to add e to the x, y. Y is 1/2. I have to add y, that is 1/2 e to the x plus c e to the minus x. Let's go to solve here. So 1/2 e to the x plus 1/2 e to the x is e to the x. So this two term is e to the x. And this term will cancel with this term. Now we say, is e to the x equal to the e to the x? Yes, so this is the solution, because e to the x equal e to the x. Okay, let's go to the next problem. The next problem says, find the integrating factors for the differential equation. The integration factors for a differential equation written in a standard form, d dy dx plus p of x by y equal q of x. The integrating factors mu of x equal e to the integral of p of x e raised to the integral of p of x ddx. So we have to find who is p of x. But this equation that they gave us, the derivative of y respect to the x plus 2 minus 1 divided by xy plus x is not written in a standard form. So I need to rewrite this equation to a standard form. Let's go to do it. So it will be the derivative of y respect to the x. So I will take this term, I will put it in the other side, plus 1 divided by y, 1 divided by x multiplied by y equal 6x minus 2. And now it's written in the standard form. Who is p of x? P of x is 1 divided by x. Who is the integrating factor? Mu of x. How you will find? Make e to the integral of p of x ddx, or make e to the integral of 1 divided by x ddx, or make e to the integral of 1 divided by x is natural log of x. And what is e? And now e to the natural log of x is x. So mu of x is x. And the problem, the question is solved. The integrating factor is x, and x is the function that I have to multiply to this equation, to this differential equation, all of them. I have to multiply by x to make possible, or here, better here, I have to multiply by x here. You multiply everything by x. You multiply everything by x, and now you have a new equation that say that x by the derivative of y respect to the x plus y equals 6x squared minus 2x. What we have done is that the left side of the equation can be written like the derivative respect to the x of the integrating factor dx by y. I can compress the right side of the equation, the left side of the equation, by x by y, because the derivative respect to x of x by y will be the derivative of the numerator by x is 1 by y, plus the derivative of y by x, plus the derivative of y by x. So I compress this in this form. And now I can integrate this equation and I can get a solution to this equation by integrating in both sides of the equation to find y of x. Let's go to the next problem. The natural log. Now this problem says find the integrating factor. They give you the equation in standard form. So I can see clearly that if my standard form is d dy ddx plus p of x by y equal q of x, I can see that the q of x is 10x, but I have to pay attention to the p of x. P of x will be 2x in this example. P of x is what multiplied to the y. And the integrating factor, or the mu of x, the function mu of x is e to the integral of p of x by ddx, or equal e to the integral of 2x ddx, or e to the integral of 2x ddx is x squared divided by 2. So it's e to the x squared. So the integrating factor is e to the x squared, and this integrating factor is the key factor that will solve my equation. When I multiply the whole equation by mu of x, when I multiply by e to the x squared, I will be able to compress the left side of the equation as the derivative of y multiplied by mu of x. Let's go. So the solution to this problem, find the integrating factor. The integrating factor is e to the x squared. Now let's go to solve this differential equation. It's written in a standard form, so I don't have to do any manipulation to the equation. So what is p of x? The first question. What is p of x? I see p of x. The function, p of x is the function that is a factor of y. Is here the function that is a factor of y. The function that is a factor of y is the function minus 1. So p of x is minus 1. And what is the integrating factor? Is e to the integral of p of x ddx, or it will be e to the integral of minus 1 ddx, or will be e to the minus integral of ddx equal, what is the integral of 1 by ddx? What is the antiderivative of 1? Is x. So this will be e to the minus x. So this is the integrating factor that helped me open the door to solve the equation. So let's go to take the differential equation, the linear differential equation, y prime minus y equals 16, and let's go to multiply by the integrating factor e to the minus x. What will happen now? I will have this equation, e to the minus x y prime minus e to the minus x y equals 60 times e to the minus x. And the beauty and the magic of the things of this technique is that the left side of the equation can be written like the derivative respect to the x of the integrating factor by y equals 16 e to the minus x. And why this is true? Well, make the derivative. It will be it will be e minus x by the derivative y prime plus the derivative of e minus x, which is minus e to the minus x by y. And now I can do the integral in both sides. Doing the integral in both sides will means that the integral of the derivative will be the function. So it will be e minus x by y multiplied by y will be the integral of 16 by e to the minus x. So what will be at the end our final solution? Our final solution will be, well, let's go to solve this integral, is 16 times the integral of e minus x. The integral of e minus x is minus e to the minus x. So it will be minus 16 e to the minus x, because the derivative of e minus x, of the derivative of minus e to the minus x is e to the minus x. So what will be the solution? The solution will be y of x equal 1 divided by e minus x multiply by minus 16 e to the minus x. So the solution will be minus 16, and the solution is done, and we can check. If we make the derivative of minus 16, the derivative y prime, the derivative of minus 16 is a constant, so the derivative is 0. Minus y minus 16 is 16. Oh, it's okay. So 16 is equal to 16, so this is the solution to this differential equation. The mistake is the following one. You know, when I do this, the int is true that the integral of the derivative is e to the minus x by y. E to the minus x multiplied by y. Now, it is true that the integral of 16e minus x is minus 16 e to the minus x. Now, what is left? Plus c, and now the solution is indeed this one. Y of x equal 1 divided by e to the minus x, that multiply minus 16 e to the minus x plus c, and now the solution is indeed y of x equal minus 16, because e minus x divided by e minus x will be 1, plus c divided by e minus x plus c e to the x. This is the solution to the differential equation. So pay attention that when you do the integrating factor, you don't need to add the c, but at the end you need to add a c, okay? This is the solution. Now we go to problem 7, where we solve the linear differential equation y minus 1 sine of x ddx equal ddy. Wow, this doesn't look like the standard form, so we need to convert it to the standard form. So we divide by ddx, we will have vdy vdx equal y minus 1 sine of x. If we try to put it in the standard form, will be ddy vdx minus sine of x by y equal sine of x by y equal minus sine of x. And this is the equation now written in a standard form, so I can locate what is p of x. P of x is minus sine of x. I'm sorry that I write sine of x not in this way, sine of x. Okay. Okay. So what is the integrating factor? The integrating factor mu of x is e to the integral of p of x by dd multiplied by ddx. So it's e to the integral of minus sine x ddx. And what is the integral of sine x? What is the antiderivative of sine x? Minus cosine of x. Because it have a minus, it will be e to the e raised to cosine of x. Because cosine of x, the derivative of cosine of x is minus sine of x. The derivative of cosine of x is minus sine of x. So I found the integrating factor. What is my second step to solve the differential equation? We multiply everything, the equation in standard form, we multiply by the integrating factor. So this is the equation in standard form, and we have to multiply this equation by the integrating factor. So it would be e to the x, e to cosine of x, by ddy ddx minus sine x e to cosine of x by y equal, I see here, equal minus sine of x multiplied by the integrating factor e cosine of x. What I have done is multiply the whole equation by the integrating factor e cosine of x. And I have obtained this equation. What is the beauty? The magic here is that the left side of the equation can be written like the derivative respect to the x of the integrating factor. The integrating factor is e cosine of x multiplied by y. If you produce the derivative of this, you will find this, exactly this. Do it. So this will be minus sine x e cosine of x. And what is the advantage of doing this? That now I can do integration both sides of the equation. And when I do integration both sides of the equation, I will do e cosine of x by y equal minus the integral of sine of x e to cosine of x ddx plus c. This c comes from the integral that I did here. Okay, or from the integral that I will do here. So what is the solution? The solution will be based on this integral, on the integral of sine of x e to cosine of x ddx. How we solve this integral? Well, this integral is solving if you write u equal cosine of x, and ddu will be minus sine of x ddx. This integral is the integral of e to the u ddu. Or, so the integral of e to the u ddu is e to the u. So this will be e to the u. And e to the u is e cosine of x. So the integral, this integral is e cosine of x plus c. So now I have e cosine of x multiplied by y equal e cosine of x plus c. And now I have y of x. What is y of x? Now, to solve for y of x, we will have y of x equal 1 divided by e cosine of x multiplied by e cosine of x plus c. So y of x will be e cosine of x divided by e cosine of x is 1. So e cosine of x divided by e cosine of x plus c divided by e cosine of x. So y of x will be 1 plus c e minus cosine of x. And this is the final solution to this differential equation. You can check always, you can go to the differential equation, plug in y of x, and you will see if this is the solution to the differential equation that we have solved. Let's go to the next problem. Now let's go to solve the problem number 8 that say find the solution to this differential equation y prime plus y tangent of x equals secant x plus cosine of x. But now the problem say that you find the particular solution, the solution for which y of 0 is equal 1. And this information will tell you who is the c. So let's go to apply the same technique, meaning to find first the integrating factors. We pay attention to the p of x. We find the integrating factor like e to the integral of p of x dx. If you do it, you will find 1 divided by cosine of x, because it will be e to the integral of p dx ddx. P dx is tangent of x, so it will be the integral of tangent of x ddx, but the integral of tangent of x ddx is minus the natural log of cosine of x. So it will be 1 divided by e to the natural log of cosine of x, but e to the natural log of cosine of x is cosine of x. So it will be 1 divided cosine of x, which is secant x. So we multiply the differential equation by the integrating factor, which is secant x. When we multiply the differential equation by the integrating factors, we have an equation that says secant x y prime plus secant x tangent x multiplied by y equals secant square of x plus secant cosine of x. And now the magic is that the left side of the equation can be compressed as the derivative respect to the x of y by the multiplied by the integrating factor by secant x. Y multiplied by secant x, the derivative of this function is all this left, right side of the equation. So we now integrate both parts of the equation. When we integrate both parts of the equation, we have y secant x equal the integral of secant square of x cosine of x secant x ddx plus c. So y secant x is the integral of secant square of x. Now cosine of x multiplied by secant x, because secant x is 1 divided by cosine. Cosine multiplied by secant is 1. 1 ddx plus c. So our integral will be the integral, two integrals, the integral of secant square of x ddx plus the integral of 1 ddx plus c. What is the antiderivative of secant square of x? Tangent of x, because the derivative of tangent of x is secant square of x. So y multiplied by secant of x will be tangent of x plus what is the integral of 1 ddx? What is the antiderivative of 1? Is x. X plus c. So what is the final solution? The final solution y of x is tangent x divided by secant x plus x divided by secant x plus c divided by secant x. But because secant x is 1 divided by cosine of x, The solution will appear in terms of cosine of x, like y of x equal x cosine of x plus c cosine of x. And tangent of x divided by secant of x is sine of x. But now we have to impose the initial condition. The initial condition of the particular solution is when y of 0 is 1. So when y is 1, the x is 0. So when y is 1, the x is 0, so we will plug in x equals 0 on this equation to find c. And we impose that y is 1. So 1 equals sine 0 plus 0 cosine of 0 plus c is cosine of 0. Cosine of 0 is 1. And sine of 0 is 0, and 0 by cosine of 0, this is 0 because cosine of 0 is 1, but 1 multiplied by 0 is 0. So we finally found c equal 1. So our final answer is that the solution to the differential equation, that the particular solution to the differential equation when y of 0 is 1 is the equation sine of x plus x cosine of x plus c 1 cosine of x, c cosine of x. And of course, I have said multiple times, you can check by going to the differential equation that this is the solution. Let's go to the next problem. Now we are going to solve problem 9. Problem 9 is about a differential equation that occurs when a body is falling in the presence of friction force. So this is the positive direction, going downward is the positive direction. So mg is going downwards, mg is positive. And the friction is going in the opposite direction of the velocity. The velocity is being positive downwards, so the friction force is going up. So when we have a body that is subject to forces, what forces? The weight, mg, and the friction force. The total force produces acceleration. So the body is being accelerated in the direction where the force is bigger. In this case, the kv is very small at the beginning because the object starts with velocity 0. So imagine that this is a drop of rain that is falling from the sky, from the clouds. Or imagine this is someone who is falling in a parachute from 10,000 meters. So he's subject to two forces, the weights going downwards and the friction force going upward. We take the positive direction going downward. So the total force produces acceleration, mass by the acceleration. What it say, Newton's law, it say, make the sum of all the forces, and the sum of all the forces is the mass by the acceleration, multiplied by the acceleration. So the sum of all the forces is mass by acceleration, and acceleration is the change in velocity per unit of time. Acceleration means change in velocity per unit of time. So what are the forces? Positive forces, mg going downwards. Negative force, the friction force, kv going upwards. Upwards is negative in this model that we are developing. We are developing a differential equation for the velocity, how the velocity will change. So at the beginning, the velocity is almost 0. So this is the floor, this is the floor. At the beginning, the velocity is 0. So this term kv is very small. Mg is constant all the way. So as the mg is accelerating the body gains velocity, the velocity increase. So k by v is going to be bigger because the velocity will be bigger. And it arrives at a limit point when the mg is equal to kv, and in this moment the two forces are equal and different directions, so the total force is 0. So the acceleration is 0, because if the total force is 0, the acceleration is 0. And at this instance, you achieve the parachute of the drop, achieve the limit velocity. Now the acceleration is 0, so the velocity doesn't change. So let's go to write the equation. The equation will say the sum of all the forces, mg minus kb, mass by acceleration. Solve for ddv, ddt will be g minus k by m, multiplied by v, so this is a differential equation. Instead of y, we find v here. Instead of x, we find time t. This is a first linear differential equation. Now b equal k divided by m. So the equation will read g minus v by v equal the derivative of v respect to the t. Is a linear differential equation? Yes. Put it in a standard form. ddv plus b by v equal g. So the p of x is v is a constant. So I need to solve this differential equation. How we will solve? Well, we know how to solve different linear differential equations. How we solve? We found first the integral factor, the mu of t. So p of t is v, so the mu of t is e to the integral of p of t dt. So it would be e to the integral of v by t dt. It would be e b multiplied by t. evt is the integral factor. With second step, we multiply the whole equation by e to the vt. If we multiply by evt the whole equation, we will find this equation that you see here. This equation is the equation that you will find. Now, what is the advantage of this? What is the advantage of multiply by the integral factor? The advantage is that this equation can be written as the derivative of respect to the t of the velocity by the integral factor. V by e bvt, b by e to the bt, the derivative of this is exactly this as we have seen in all the previous examples. So now it's easy to make the integral. The integral of the derivative with respect to the t is v by e vt. So v by e vt would be the integral of g by e vt plus c. Now I can find v of t. What will be v of t? Well, let's go to do first the integral here. The integral of g by e vt is g divided by v e bt plus c. So now let's go to find v of t. V of t will be g divided by v e bt divided by e vt plus c divided by e vt. Perfect. Let's go now to reduce a little bit v of t. V of t will be, because e to the vt divided by v to the vt is 1, will be g divided by v plus c e minus vt. C divided by e vt is c e minus vt. But remember that b, we have defined v like k divided by m. So v of t is g divided by v multiplied by m divided by k plus c e minus vt. Normally, the initial condition is that the drop, the raindrop or the parachute will start with velocity at t equals 0 equals 0. So v of 0 will be 0, or what is the same? At t equals 0, the velocity is 0. So if we impose this condition to this differential equation, it will say that when t equals 0, e to the 0 is 1, so 0 will be g by m divided by k plus c, and this allows me to find the c. So the c will be minus mg divided by k. So what will be v of t now? So I will substitute the c that I have found for his value. So it will be v of t equal mg divided by k. mg divided by k plus c, but c is minus mg divided by k, a minus mg divided by k multiplied by a to the minus k divided by m multiplied by t. So v of t, if you take common factor mg divided by k, will be v of t will be mg divided by k that multiply 1 minus a minus k m multiplied by t. And if you draw these functions, v of t will be 0 at the initial instance, at the initial time. As the times go, the velocity increase. The velocity is going downwards positive. The velocity increase, the velocity increase, the velocity increase, and it arrives at moment when the velocity is asymptote to the value mg divided by k. So the limit velocity that the parachute is going to have in the presence of friction force is mg divided by k. It's easy to find this velocity from the equation because m by the derivative of v respect to the t is the sum of all the forces. And the sum of all the forces is mg minus kv. If the derivative of v respect to the t is 0, it means that the object is not gaining any velocity. It's stable, it's a constant velocity. So from this equation I can write 0 at this instance when mg is equal kv, when the force going downwards is equal to the force going upward. At this instance, mg minus kv is 0. And at this instance, mg is kv. So the limit velocity at this instant is mg divided by k. And now again, we find the same result, mg divided by k, as the limit velocity. Okay, there is one more problem that I'm not going to solve. I leave you to solve. I'll see you soon. The last problem is this one. I expect you to solve. I expect you to draw the function omega of t, the weight as a function of time. This differential equation is being solved, can be solved like the previous one. It's a linear differential equations that is being solved by finding the integral factor, but also can be, the solution can be found by separation of variables. So this equation, an equation from problem 9, can be found using separation of variable. We have used the methods of solving a linear differential equation, first order linear differential equation, but you can try to do it separating variables and you will obtain exactly the same result. I leave you this problem for you. Good luck, and I'll see you soon.